Hi everyone, in this video I'll be looking at chapter 7 functions and graph, and for this worksheet we'll look at how do we estimate the gradient of a curve by drawing a tangent. Okay, so in this worksheet you'll learn a new word called tangent. What is a tangent? So let's look at this diagram here. Okay, if I have a curve something like this, this is a curve. This line over here is called a tangent to the curve at the point A. Point A is marked by a cross here. Okay, this line here is called a tangent to the curve at point A. You can highlight this. Okay, the gradient of the curve at this point. Let's say this curve, right, has many different gradients. You see that the curve, right, is becoming steeper and steeper as I move along this curve in this direction. The curve is becoming steeper and steeper. Therefore, when I draw a tangent, the tangent at point A, it can tell me the gradient of the tangent to the curve is the gradient of the curve at that point. Okay, so let's look at some more examples. Let's say, right, if I have this diagram over here, if you look at the bottom of the page, this is a simple curve like this. Okay, the two lines in green here, this is line 1 and this is line 2. These are all also tangents to the curve at point P and at point Q. Okay, these are tangents to the curve. They are lines that touch this part of the curve once at point P, and the gradient of this straight line here can tell us the gradient of the curve at that point. Okay, so in this worksheet you will learn how do we draw a tangent. So take note, you can see that this blue line here is not a tangent to the curve because you can see that it doesn't tell us how steep the line is, how steep the curve is, and over here point S also, this blue line here is also a tangent to the curve. Okay, so what does it mean by tangent? So let's do a simple recap first. First, we must first understand what is the meaning of gradient. We have learned before, gradient measures how steep a line is. If a line is upward sloping, this is a positive gradient. If the line is just horizontal like this, the gradient is 0. If the line is downward sloping like this is a negative gradient. Okay, so once we understand this, now we can now go further. What is a tangent to a curve? Okay, so we must first understand the meaning first. A tangent is a line that can tell us the gradient of the curve at that point. So let's look at some simple examples. Let's look at example 1. If I have this point over here, I mark it with a cross. This black line here is called a tangent. Okay, what is not a tangent? This line here is not a tangent to the curve. Usually when we draw a tangent, okay, when we draw a tangent like this, okay, the area underneath the curve on the left and right side is usually the same. Okay, so over here, this line here, you see it cuts the curve more than once at this point over here as well. This is not a tangent to the curve. It will not tell us accurately how steep the curve is. And lastly, what is a bad tangent? You see, if I had the same curve now, I have this line here. You see this line is a straight line that cuts this point, but there's no area under the curve here, whereas on the right side you can find some area here. So this is not a good tangent. The best tangent is the one drawn in example 1, whereby on the left and on the right side of the curve, underneath this tangent, the area is about the same. Okay, so this may not be easy to draw, so you need to practice a bit to get used to learning how do I draw nice tangents. Alright, so recap again. If the question say how do you calculate the gradient of a curve at a point? First, draw the tangent first. Then on the tangent, choose 2 points along the line that is easy to read. Then we can calculate the gradient of the tangent by using a y2 minus y1 over x2 minus x1. Then the gradient here is the gradient of the curve at a point. Okay, so let's do some practice so that you can better understand. Okay, I'll need you to have a pencil as well as a ruler in order to draw tangents. So please prepare that. Then now let's look at the practice question. Okay, part A. By drawing a tangent, estimate the gradient of the following curve at point A. So let's look at part A. Okay, this is the graph given to me. So how do I draw a tangent? I will place my ruler. Okay, take out my ruler. I will first put my pen at point A. Keep your pen at point A now. Okay, now I'm going to shift this ruler. Okay, I'm going to shift my ruler and place it against the pen edge here. You can see what I'm doing. This is the ruler now. I place it at the pen edge. Now I want you to tilt the ruler. Okay, find the perfect spot such that this ruler here, when I place this ruler here, the left and right side underneath the area under the tangent, under this line here is the same. So for example, if I place my pen at point A, the ruler shouldn't look like this. Why is it wrong? Because you can see that here there's nothing underneath between the ruler and the curve, whereas here got a lot of space. So what I want to do is I will adjust the ruler, tilt it a bit, such that I get something like this here. Okay, so you can see if I put at this part here, there is this area underneath the ruler, between the ruler and the curve. This area underneath the ruler and curve as well, and it's about the same. So once I've done that, now I will draw a line. I'll draw a simple line like this. Okay. Now once I've drawn the line, now I will estimate the gradient of the curve at point A. So over here, the gradient of the curve at point A is simply to find the gradient of this tangent over here. How to find the gradient of this tangent? Simply we choose 2 points on this tangent. For example, if I choose to take, let's say I look at the curve, I choose 2 nice points. Maybe I have, I estimate, maybe I have this point here. This point, the coordinates I can read downwards. Okay, this one is 1.8, comma, I check the y-axis, 3. Okay, I choose another point on this side part. Maybe let's say I can choose, maybe I can choose this point here. Okay, this point here I can read as negative 0.2, comma, 0.4. Okay, so how to find gradient? You should know the formula y2 minus y1 over x2 minus x1. Okay, so over here y2 minus y1, I can take 0.4 minus 3. Okay, I can plug in 0.4 minus 3. Then x2 minus x1, negative 0.2 minus 1.8. Okay, so once I've done that, then now I'll go and calculate using my calculator. 0.4 minus 3 over negative 0.2 minus 1.8. You should get 1.3. Okay, and this is for part A. Alright, now can you do the same thing for part B? Try by yourself first, pause this video, try drawing the tangent to this curve by yourself first, then continue playing this video to see how we draw the tangent. Okay, so now I'll try. Okay, so same thing. For part B, I'll place my pencil at point A. Now I'll put my ruler here. I will tilt my ruler at point A. Then I adjust it such that I can get the area between the ruler and the curve on both sides to be about the same. So I go and tilt and adjust. So over here, I'll turn the ruler until I get a perfect point. Maybe over here. I think here looks good. Okay, so I'm gonna now draw my line. My tangent should look like this. Oops, I get cut off. My tangent should look like this. Okay. We can see, is it clear? Yeah. Okay, so my tangent should look something like this on your paper as well. Then once I draw my tangent, to find the gradient of the curve at point A. Okay, this is the tangent at point A. I'll choose 2 points along this tangent line. So let's say I choose 2 nice points that you can read the numbers of the x-axis and y-axis very easily. Maybe I can pick here. Okay, this number is simply 1, 3. This is the coordinates. I pick this point here as well. This is 2, 1. X, remember it's x followed by y when you write coordinates. Then now I calculate my gradient. It is always y2 minus y1 over x2 minus x1. I choose y2 minus y1, maybe 1 minus 3. Okay, 1 minus 3 over 2 minus 1. 2 minus 1. This will give me negative 2. Okay, and this is the answer to part B. Okay, so you can now go ahead and try part C and D by yourself. Pause this video, try part C and D by yourself first before continuing this video. I will now continue this video. Okay, so over here for part C, to draw the tangent, this is the line here. I put my ruler, my pencil at point A. Then I put my ruler here. Then I check left and right side. Is it about the same? Looks about the same now. Okay, so over here, I will get draw the pen. Okay, here. Okay, your tangent for part C should look something like this, and you should notice something familiar. This is a horizontal line. We know that for any horizontal line, we go back again, recap. Any horizontal line gradient is 0. So I don't need to calculate this. I know straight away from here, if this is a horizontal line, the gradient is straight away 0. Okay? So this is for part C. Okay, this is a horizontal line, gradient is 0. Then for the last part over here, okay, part D, same thing, I'll put my ruler. So for part D, some of you may get confused. How do I draw my line? Do I draw it above this part here or is it below? Okay, so if you think about it, right, over here, for part D, okay, we can try drawing the tangent to the curve. Okay, you can do your own estimation. In this case here, I think the tangent line will look better somewhere along like this. I think the tangent line, whether you draw above or below, should be about the same. Okay, so if I were to draw my tangent, it should look something like, let's say, let me measure. It should look something like, let's say, here, I think. Okay, so it should look something like this. I think something like this. Okay, area. Okay, may not be easier, so you have to measure your ruler carefully, then make sure you can get this accurately. Okay, so over here, my tangent, maybe I think it looks something like, wait, I think it looks something like this, if I'm not wrong. Okay, oops. Okay, so maybe my tangent line should draw something like this, I think. Is it touching my point? Wait, okay, it's a bit hard to draw on my iPad. Okay, so okay, so I think my line can look something like this. Okay, okay, I think this should be okay. So over here, once I draw the tangent, then I'll choose two nice points along this line. Let's say I have maybe about this point here. This is negative 1.246, comma 3.2. And let's say I choose, cannot really see, but maybe I choose this point here. Maybe this point, okay, I cannot really see, but this is negative 0.4, comma 0.8. Okay, so over here, once I've chosen two nice points, I can then now proceed to calculate what is the gradient. So the gradient for this line is simply, okay, the gradient for this line, I can calculate this to be y2 minus y1 over x2 minus x1. Okay, y2 is simply 0.8 minus 3.2 over negative 0.4 minus negative 1.6. Okay, calculate this in your calculator. You should get, let me calculate as well, 0.8 minus 3.2 over, okay, you should get negative 2. Okay, so there's usually a plus minus range when we draw when we calculate gradients by drawing tangents. That's why the question usually say estimate. Okay, so you just need to make sure your answer is as close to the actual value as much as possible. Okay, this is for the practice questions here. Alright, so now let's look at example 1. Okay, example 1 here, I'm given a graph connected by the equation y equals to x squared minus 4x. Okay, part A, by drawing a tangent, find the gradient of the curve at a point where x is equal to 2.8. So if I were to look at the graph, when x is 2.8, I hope you can recognize that this horizontal line is your x-axis, the vertical line is your y-axis, x equals to 2.8 is along this point here. Okay, therefore, if I were to draw a dotted line down on this graph here, this is the point x equals to 2.8. Okay, this is 2.8. So how do I draw a tangent? Good, so now I'll place a ruler. Okay, so same thing, draw a tangent at this point. Place a ruler here, your pencil put at the part of the curve where x is equal to 2.8. Then now I'll put my curve and slowly tilt it. I check. See, when I put my curve at this point here, area here seems a bit small compared to the area under here. I adjust a bit more. Okay, so I'll tilt the ruler, tilt it more. Then I check which part seems the best. Okay, I think here looks good. Something like this. Okay. Okay, I think here looks good. So once I've chosen where to place my ruler, I'll draw a tangent using my pencil. Draw a straight line that will connect the curve at this point. Okay. Okay, and this is the tangent, my drawn tangent to the curve. Okay. This tangent should only cut the curve at one point, at this point here. So now, part A, by drawing a tangent, find the gradient to the curve. To find gradient, I'll choose 2 points first. Let's say I choose, this point here, very nice. 5, 0, the coordinates. I choose another point. Let's say, over here. Maybe this point is nice. I can read the coordinates. This is 0.4, this one is -7. Okay, so for part A, gradient, gradient is equal to, let's say y2 minus y1, over x2 minus x1. Okay, y2 minus y1, 0 minus -7, maybe I use blue pen, 0 minus -7 over 5 minus 0.4. Okay, y2 minus y1 over x2 minus x1. Then I key this into my calculator. The gradient I should get should be 0 minus -7 over 5 minus 0.4. I get about 1.52, round off to 3 SF. Okay, maybe usually there's a plus minus, maybe about plus minus 0.2. Okay, so you check your working, hopefully it's accurate as well. Okay, so this is for part A. Okay, part A done. Part B, the gradient of the curve at the point h, k is 0. So for gradient to be 0, we know that the gradient of the curve to be 0, it must be a horizontal line. We must have a horizontal line for the gradient to be 0. So when the question say, draw the tangent to the curve at the point h, k, whereby the gradient is 0, I look at the graph. Which part of the graph do you think if I draw the tangent, I'll get a horizontal line? The most logical part to think would be at this point over here, at the lowest point of the graph. When I draw a tangent, it will just be a straight line here, because the area between the curve on the left side and right side will be about the same. So that means that for draw the tangent, if I draw the tangent now, okay, it should mean that the tangent should be at this point over here. Okay, okay, let me mark in red. This point here should be the point whereby the tangent has the gradient of 0, because it is a horizontal line. Okay, so I read out the coordinates from here. Looking at this point here, the coordinates are 2, -4. Okay, so very simply, draw the tangent, done. Part 2, hence find the value of h, k. Since this is the coordinates, h is 2, k is -4. So very simply, therefore, h is equal to 2 and k is equal to -4. And this is for part 1 and part 2. Alright, so this is for example 1. Let's now move on to example 2. Okay, example 2, you need a piece of graph paper. Please take out a piece of graph paper. Okay, I'm given this question here. Variables x and y are connected by this equation here. Okay, and therefore I am given the values of x and y with the corresponding values up to 2 dp for this equation here. Okay, find the value of p. P is over here. How to find the value of p? Very simple. X and y are connected. All these values here are connected by this equation. That means that when x is equal to 1, y equals -2. When x is equal to 2, y is equal to -1, based on this equation here. So therefore, when x is equal to 5, find y. By this simple equation here, when x is equal to 5, okay, y will be equals to -2/5, based on this equation here. Okay, so you calculate very simply, -2/5, I write in decimal form 2 dp, I'll get negative 0.40. Okay, therefore, answer the question, P equals to negative 0.40. This is for part A. Okay, so now let's look at part B. Part B over here. Using a scale of 2 cm to represent 1 unit on the horizontal x-axis and 2 cm to represent 0.5 units on the vertical y-axis, draw this graph for the range of x between 1 to 6. Okay, so over here, very simply, we can now sketch my graph. So you need to take out a piece of graph paper now. Okay, I've plotted, placed the table of values here and also the scale, so you can refer very easily. Okay, this question wants me to draw x from 1 to 6. On my x-axis, 2 cm to 1 unit. So every big box like this, 10 mini squares, 2 cm is 1 unit. Okay, so over here, since my x is only positive and my y values are mostly negative, I'll plot my graph something like this. Okay, so my x-axis here, I have 2 cm is 1 unit, so this will be 1, 2, 3, 4, 5, 6. I label this as my x-axis. Please label this as x-axis. Y-axis, 2 cm is 0.5 units. So that means every big box, 10 mini squares, 2 cm, 0.5 units. So if this negative 0.5, this will become negative 1.0, negative 1.5, negative 2.0. Okay, this is for my y-axis. Then I go upwards, one big box, this will be 0.5 y. I label my vertical axis as well. Okay, so very good. So now I've done my axis. Now let's plot the points. When x is equal to 1, y is negative 2. When x is equal to 1, y is equal to negative 2, which is this point over here. Okay, next one. When x is equal to 2, y is negative 1. This point here. When x is equal to 3, y is negative 0.67, which is estimate, this is negative 0.6, 0.7, so it should be somewhere about here. Okay, when x is equal to 4, y equals to negative 0.5 here. When x is equal to 5, y is negative 0.4 here. And when x is equal to 6, y is negative 0.33, which is somewhere over 4, 3, somewhere about here. Okay, so therefore, now sketch the graph. You should get a simple sketch like this. I connect all the points together. It should look something like this. Can I connect nicely? Oops, I need to draw nicely. Yeah. Okay, I'm gonna try my best to draw nicely on this iPad. Okay. Okay, so your curve should look something like this if you are able to sketch it accurately. Okay, this is for part B. Okay, then we label the equation of the curve. This is y equals to negative 2 over x. So I'll label y equals to negative 2 over x. I've sketched this graph. Okay, let's now look at part C. Okay, part C, by drawing a tangent, find the gradient of the curve at point A. Point A is given 2, negative 1. So let's mark out point A on the curve first. 2, negative 1. It is this point over here. Okay, so we label this point out. This point here, point A. Draw a tangent to the curve at this point. So very simply, I will draw a tangent to the curve at this point here. So remember the steps again. To draw a tangent, first place your pencil at this point here. Now take out your ruler. Okay, tilt your ruler such that you can adjust this. You can adjust the ruler such that on the left and right side between the ruler and the curve, the area is about the same. Okay, so therefore, if I were to rearrange and adjust my ruler, I should get something like this, I think. Okay, by the left and right side area seems to be about the same. Okay, so you can check our left side and right side area. It looks about the same. I can now take my pencil to draw a tangent. Okay, and this is my tangent for C part 1. Okay, so now once I draw my tangent now, find the gradient of the curve. So gradient of the curve is the gradient of this tangent. I choose two nice points along this tangent. I can see the gradient, this tangent cuts this x-axis very nicely. Here is 4, 0. The tangent also cuts the y-axis very nicely. Here is x coordinate first, 0, negative 2.0. Okay, so therefore for C part 1, okay, gradient of the curve at, let's label, gradient of curve at A is equal to gradient of tangent that we just drew. Okay, so to find gradient of tangent, I take y2 minus y1. Over here, y2 is 0 minus negative 2 over 4 minus 0. Okay, so let's calculate that out. 0 minus negative 2 over 4 minus 0. Okay, you should get half or 0.5. And this is your answer to part C, part 1. Okay, and last one. Find the gradient to the curve at x equals to 4. So let's look at x equals to 4. When x is equal to 4, I can see that this is the point I'm looking at. I will highlight this in yellow. Okay, x equals to 4 is this point over here. Okay, I highlight this point, this point over here. Okay, so to draw a tangent at this point, same thing, I will take my ruler. Okay, first place my pencil at the point of the graph here, then adjust my ruler accordingly. Okay, so I'll adjust my ruler on the graph paper and adjust it. Okay, then I check. Okay. Okay, so I think if I adjust and check carefully, okay, the tangent looks something like this, I think. Okay, left and right side looks about the same. Okay, between the ruler and the curve. Okay, so therefore I'll now sketch my tangent. I'll take a black. Okay, I'll take my pencil, sketch this line here. Okay. So I've done that now. Now I'll find the gradient of this new line over here. Okay, maybe I put this a different color so you can see more clearly. Maybe I'll choose green. Okay, so along this new tangent here, okay, I'll choose two nice points. I can see that I can find one nice point on here. Okay, this point is 0, negative 1.1. Okay, then let's choose another nice point. I can see that I have let's see which nice points do I have? I can see that the tangent passes this point here. Okay, I will mark this for cross. This point here. Okay, this point here, the coordinates is 5.6, negative 0.25. Okay, so therefore, to find the gradient at this point, very simply, gradient is simply equals to y2 minus y1. My y2 is now negative 0.25 minus negative 1.1. Okay, negative 0.25 minus negative 1.1 divided by, okay, negative 0.25 minus negative 1.1, then 5.5 minus 0. Okay, divided by 5.5 minus 0. Okay, so now calculate this in your calculator. You should get 5.5. I will get 0.155, round off to 3 SF. Okay, and that is my final answer for C part 2. Okay, so with that, I hope that you have now learned how do we draw tangents to the curve. We must use a ruler and do a bit of estimation. And once I can draw a good tangent, the gradient of this tangent can tell me what is the gradient of the curve at the point where I draw the tangent. Okay, so that's the main point of this worksheet. I hope we have illustrated that through the examples. How do you draw tangents? And once you are done, you can now proceed to try the question stated over here. Alright, so with that, this will be the end